All right, so we'll be talking about now. This is now lesson 2 or lecture 2, hybridization. What is this hybridization? We'll define it and you will see different type of hybridization. All right, so without even wasting your time, let's go. All right, so when you talk about hybridization, all right, we mean it is the process by which we mix two or more atomic orbitals to create a new covalent bonded orbitals in a molecule. So what we are trying to say is we can mix two or more orbitals. Let's say SS, I'll mix SS, I'll mix these two orbitals to form actually S2, whatever. So I'll mix them. These orbitals that you see there, they should come from the same energy. This should be 1s and also this should be 1s. So what the new orbital that's formed is known as hybrid orbital or hybridized orbital. All right, so that's how it will be called. So orbitals are combined when bonds forms between two atoms in a molecule. So two orbitals has to combine. In fact, the best way to use, they overlap. All right, so this orbital they overlap with this that orbital to form this bond there. All right, so valence electrons are the electrons that are located in the outermost shell. So we could see electrons there. Let's say 2 electrons in the first shell, then the second one, they suppose there are 3 electrons. All right, so if there are 3 electrons, these are the electrons that will be responsible for the overlap of orbitals. So because orbitals are found within these shells, so the electrons are also found within those shells and specifically in the orbitals. So those orbitals, they should combine with the other orbitals of other element. Okay, they should combine to form the or to fulfill the octet rule, to make really, to make the 8th rule of electrons in the last shell than first shell. So that's what will be happening. Okay, so we are talking about these valence electrons. So remember, there is a valence and valence electrons. So when we talk about valence electrons, those are electrons in the outermost shell of an atom. Okay, in other words, these are electrons that can be gained or lost. So it's a charge. The raising power of an element is called a valence. All right, it's called a valence. So they lose or gain during chemical reaction. That's the reason why some metals or elements can lose, like sodium will give a +1, then other elements like magnesium will give a +2. Then other elements like oxygen will gain by what? -2, just like that. So those are valences. Okay, they are the number of electrons involved in the bonding whenever that element undergo a chemical bond. So let's go. So the types of hybridizations we have, there are a lot. Okay, there are 4 main one. There are 3 in fact. So the types of orbitals involved in mixing the hybridization can be classified as sp, sp2, but they are supposed to raise the power, sp3, sp3d, sp3d2, sp3d3, sp3d4 until sp3d5. Okay, so you can go, but in our study we'll be much concentrating on just these ones. All right, because at our level we just concentrate, but when you advance the chemistry stuff, you'll be able to actually advance. So when you say sp, equal amount of, so when s and p orbital combine, all right, when s and p orbital combine, that means both there are 2, so I can say 1 over, all right, so I'll say 1 over 2, the total times, they should give 100%, but since for 1, let's say for s it will be 1 over 2, so that will give us 50%, right? So in sp hybridized, by the way, this hybridization should be of same energy level. So if it is 2s, then we should combine it with 2p. All right, So that's how we should combine them. So if we are to form now this, so we should form 2sp. This is the energy level that they have. So the hybridization is sp. The orbital, these are orbitals. Remember we talked about them in lecture 1. So now we are seeing how they combine. We are now discussing how they combine. So sp, this means that the contribution in that bond is 50% s character and also 50% p character. Okay, so that's the reason why sp and so sp gives 50%, 50%. All right, so we can find the molecules that can give sp. So a molecule X should be bonded to two things for it to have sp, because there are two orbitals there. So we can have this and this. Let's say this is A and this is B. You get? So this means that this is sp hybridized. Okay, so a molecule chemistry, they should be same, but we don't care anyway. We just want like the number of bonds. So we have 2 and there are 2 orbitals there, okay, or 2 electrons if we are to say in that way. So they contribute 50-50 character in that bond. Suppose this one we have C, okay, CH2 like that, then like that. No, this should be a triple bond because we have 2 hydrogen there for this one. Okay, so hydrogen there. So this carbon, we actually, the method of studying now, I mean you're studying this organic chemistry, is carbon. Okay, so we are now will be talking about everything about carbon. So this carbon is bonded to 1. This, despite having 3 bonds, this is considered as 1 bond. You get? Even if it's 1, it's also considered as 1 bond. Okay, so the bond that we consider is 1 to give that hybridization. So it means we have, for this carbon we have 1 there and 2, which is sp. You get? So sp hybridized. So even there for fluoride, difluoride, barium difluoride, it's still the same. Okay, still the same. So that is for sp character, I mean sp hybridization. What about sp2? So this means that they are coming from the same energy. It can be 2 and also what, 2p2 there. Okay, it's just the increase in the number of electrons, otherwise there is nothing much. So once we combine these to get 2s what, p2, like that. So this will be our final base. So how do they combine it? So it means that for s we have 1 over, there are 3, right, times, there are 3 things, there's 1 there and 2 from s, right, from p, so total 3 times 100. So that means that when you multiply that times 100, you get something like, for s now is 33.3%, like that. So that's the character it contribute. Remember, the higher the s character, the more the bond will be very strong, because s is much to the nucleus than these other orbitals. That's how they arrange in those atoms. So we have the nucleus there, so we have also s and p within this shells. Okay, so that means that s is much close to what, to the nucleus. So the more you have s, the more you have s character, I mean the more the bond will be very strong. So you that point is normally asked. Pay attention to it. The more s, the more strong the bond will be. Why? Because s is close to the nucleus. Okay, so you can give other explanation, but that's the best. So the best example we can give is there, where boron is bonded to 3 things, so 3 hydrogen. I said we consider the number of bonds. Okay, so the bonds 1, 2, 3 means we have s only can accommodate 1, so we don't put any other number there. Okay, so there we'll put 2 to make 3, that 3 which we have. Okay, so that is the s from 1 there and the p2 there. So that means they are totaling to what, to 3. So this means sp2 hybridized, or hybridization if it's a process. So that means that's the same also, that one. So last one now, we have sp3. It means we have By the way, also here to get the exact, I've explained the characters that you get. The more S, so the strongest bond is sp, followed by this, and lastly we have sp3. This means that we have how many? We have 1 there. It means 3 plus 1, that would be 4. So we need 4 bonds. Okay, no, atoms, to say, just atom, not bonds, but atom. Let us take it in terms of atom. Okay, so I can have this C with the this. How many bonds? There are 4. So that means that is sp3 hybridized. Okay, so that's sp3 hybridized. So the character now, what will happen is that the S we have out of 4, we have 1 over 4 times 100. That will give us 25%. You'll get, so 25% is the one you get. So that means that this, as you increase the number of atoms, the S character reduces, because outside the nucleus, suppose we have the nucleus there and there are other orbitals there, so the more orbitals will be participating are those that are on top of S, let's say P, and also, suppose my drawing is bad, and also this is let's say P, this is S, then this is D orbital, or within the same energy level. So you find that as you bring a lot of guys, these guys will participate more. You get the guy on outside, like the P, D. That's the reason why it has increased to sp3. So a lot of atoms will come in the shell of P. All right, that's why we have P. So other orbitals will be overlapping using P orbital, because they are a lot. If they use this one, then they will have nowhere to go. The bond is very strong here. Yes, they will be attached, but it is very strong. So that is it. So you can also get the character. Remember, the point that I want you to keep is, the more S character we have, the more the bond will be very strong. Okay, the more S character we have, the more the bond will be very strong. So that is it for this one. Know the characters. You just ratio and find the the character percentage. Okay, so that is it. We have so far three types of hybridization. We have sp, okay, sp2 and sp3. These are the one we'll be dealing with. Okay, let's go. So now exercise, give the hybridization state of each of the carbon in a given molecule. So for this one, we can see this carbon. If I'm to display a structure, we have this carbon which is bonded to 2 hydrogen, right? This carbon is bonded to 2 hydrogen, so it has again a double bond to the other carbon, but I'm just judging this carbon. So we said how many number of atoms are bonded to this one. So there are 1, 2, 3. The number of atoms bonded to this carbon there are how many? There are 1, 2, 3. This means that we have S1, there's 1 there that you can't see. Then P, how many should we put there? 2, to make that total 3. Okay, so that means it is sp2 hybridized. What of this one? Okay, what of that? So if again I'll just concentrate there, it is bonded, it has a double bond there. All right, so that carbon, it has a double bond there from the other C, from this C. Then again it has a hydrogen there, and it has a carbon for cyanide, something like CN. So it means it is, remember there is a carbon bonded there. We are concentrating on this carbon, second carbon. So this means it is bonded to 1, 2, 3. So it is also sp what? sp2. So you total there the one from S, and they are giving you sp2 hybridized. Okay, so then just try the same, still the same for this one. We have double bond there, I mean triple bond. So that means that for this one, for this carbon which is there, I'll say it is bonded to carbon. That carbon is bonded to hydrogen, right? And hydrogen, the same carbon is bonded to 3. In short, there are how many atoms bonded to that carbon? There are 1 and 2. So this give sp hybridized. You see, you can do the same as this one. We have this carbon bonded to what, and the number of just atoms bonded, we have the other carbon, so we are concentrating on this one, so it is also sp what, sp hybridized. You see, the more you have sp, as p reduces to s, you'll find that the bond is very strong. You can see even the bond when we have a lot of groups there, so the bond, you expect the bond to be very strong between these two carbons. That's a try to understand in that way. You have 3 lobes, then you are trying to put something, you find that like you do the lobes will be very strong where they are connected, 3 of them, you get. So as you increase the lobes, you find that you're increasing the s character. Okay, so this one with triple B, it actually gives 50% s character. So get that concept, I want you to get that knowledge. So try also this one. So you also this carbon, for this carbon which is there, it is what, so even this one, it is also sp, this one is sp, in fact this one is sp also, this one is all these, they are sp. What about this one? This carbon there is bonded to 2 hydrogen and the other carbon, so it is sp2. Then this one, this is sp2. Then for this one, this carbon, it's bonded to two atoms, so it is sp. Don't mind about the double bond stuff like that, just get the number of atoms bonded to that element specified, or carbon. So for this one, we have the bond there and also 2 from hydrogen, so this is sp2. Okay, there are 3 lobes, so also there we should have a total of 3. Don't write this one, so it is just sp2 to get that 3. So what are the different types of hybridization? Among sp charts, which hybridization is more electronegative? So the more electronegative is this one, like I said, please. As you increase the x character, you increase the what? The strongest of a bond. Like I explained, the different type of groups. Suppose we have s, okay, let me lab this. I've put 4 bonds. So here you have sp3, you have seen, so that is not strong. Then what about if I have this? So that will be 1 2 3, you have seen, so that is sp2. Okay, double bond or triple bond is considered one bond bonded to atom. Let's say the only atom will come here, it's one atom, not 2 atoms, because of double bond. So then again, as we reduce now, we increase this. Okay, so that will be sp, you have seen. So that means that the bond is coming down to the nucleus and is getting strong. So among of these, the more electronegative, meaning that the more strongest one which will be attracting, guys, it is sp. All right, then what are the different types of hybridization? You can say sp, sp2, sp3, or sp3d, but these are the one we use sp, sp2, sp3. These are enough to give even the geometry. We can have sp3, then d, again sp3, then d2. These are enough. These are the one, in fact, you should write for that question. All right, until 6 we are trying to obtain where we have the structure called octahedral with the 6 number of those electrons. Here we have 1 3 there plus that makes 6. So that's how you attempt that. Then this one, we have explained the type of the one which is strong is this one. So explain the basic shapes of the hybridization, like I said. So when we have sp, we are forming, let's say, a carbon bonded to 2 things. Let's say it's bonded to hydrogen and hydrogen. This carbon is the sp hybridized. So you can see they are straight, so the geometry is linear. Okay, this is a molecular geometry, not linear, it's a molecular geometry. So when there are 2 like this, sp2, it means that we can have a molecule, let's say carbon bonded to 3 things. Okay, so this is you can see there's triangle there. Okay, if I'm to connect there, anyway, my shape can't look nice, but just know that if I'm to connect there, I'm getting what? I'm getting sp2. Okay, that is it. And if you are to measure the angle there, it's 120 when divided by 3. Then sp3 hybridized, this one you also divide by 4, not really by 4, but the arrangement will look like this. We have carbon, suppose, then there are 2 things bonded there. Okay, there are 3 things bonded there. I mean there are 4 because of 1, there are 4. sp3. Okay, so this means that if we are to divide this, the angle between these, it should be 109.5. so don't forget this angle, please. Very important, this angle. They can ask you trigonal by pyramid, so it means we have 5 of them. Okay, so we have carbon there having the other bond there on top. Okay, and also the other bond, then we have 3 there in the side way. So that is trigonal by pyramid. Okay, so there are 3 in the side. As you rotate, let's say here you are rotating these 3 bonds, then these ones, they remain in the axle like that. Okay, then these ones, they are in the equatorial. All right, so these, they are in the equator, I mean around like that, horizontal. Then these ones, they are up like that. I just want to show you how we arrange to reduce repulsion. So that is it about trigonal by pyramid. So that will hold 1 2 3 4 5, meaning that we have S1 there, P3 maximum. We have formed now 4 things to be bonded. Then we put D, that means we have now 5. We have 1 there, 2 3 4 5 plus from 3. So that means we have sp3d. So now sp3d2, it is octahedral. Okay, so octahedral, how do we arrange this? A molecule have these, they should be 6. Okay, so if they should be 6, we have something up there, then 4 we have there, again 1 there. Okay, so this is what we call octahedral. Like we have something on top. Let me demonstrate this properly. Okay, so we have in the axle there, then we have 2 there. Okay, then like that. So if we are even to draw this shape like that, okay, so in short, I'm just connecting. In the axle there are 4 atoms bonded in the equatorial, then in the axle there are just 2 bonded. So that is it. When you divide that, it's to give you 180 because of what? The angle is found in the equatorial, and we have 4 things bonded. So that means 4 divided 4 times this, you get 360, the total angle. All right, so that's how we approach this. Okay, steric number. What is the steric number? Will be asked what is give the steric number for this one, or steric effect steric number though. So the steric number is the number of atoms and lone pairs around a central or specified atom in a molecule or in a compound. Okay, so if I'm to say, suppose I light like for oxygen. Okay, I mean for H2O. So if H2O has those electron lone pairs, it means I have the steric effect is 1, 2 number of bonds, then plus these lone pairs. So it means steric effect is just steric number is equals to 3. You count the number of lone pairs and you count the number of atoms. Yes, so steric number is a bond pair. So you have a bond, a bond arrow plus the lone pair of an electron. Like I said, you include because they actually help us to know the hybridization, even the geometry of a molecule. Okay, so for example, we have 2, the steric effect is 2. It can be 2 lone pair electrons or just 2 atoms. So the hybridization will be what? sp. This one will be sp3. Then the shape is linear, the shape is trigonal, the shape is tetrahedral when we have 4 of them. Okay, So we have tetrahedral, trigonal, something like that. So these are the hybridization that we have. Okay, so final task. So sp hybridization will be the sum of 3 bonds or one lone pair to make 4. All right, or it can be 3 lone pair and 1 bond. Okay, so indicate the atoms are sp hybridization. The indicated atom are sp hybridization. We can see I said sp3, so we have 1 2 3 4. So that means we have sp3 there to make 1. There's the one that you can see there to make 4. All right, then again we come here, we have for this indicated atom we have 1 2 3 4. You have seen it is also sp3. Coming to this one, it is bonded to 2 hydrogen. Okay, and also the bond that you can see this arrow, the black arrow, and also the lone pair. So we have 1 2 3 4. It is also sp what 3. Okay, even this one I will say this is sp2 hybridized. So we can see this carbon here, this they are talking about indicated one. So this oxygen there is bonded to 1 2, I mean the steric effect, then here you consider as 1, so that will be sp2. all right, then coming to this one is also this we consider as 1 2 3. okay, so that means 1 2 3, that means sp2. Then also here we have what we have for this one we have sp, so we have 1 2 3, so sp2 also. Even this one we have 1 2 there 3. okay, so sp2. So in short, the trick is just try by all means to see the number of electrons in pairs, because in each bond there are how many? There are 2 electrons there. So just include those lone pairs you'll be finding whenever you actually future range. Include the number of hybridization. So this actually marks the end of hybridization lecture 2 of 260. So this is CH260. okay, it can be also ICH260. so that gives, we takes biology, pure biology, industrial chemistry, education chemistry, and also just the major chemistry. So you all take this one. So pay attention, follow this list or playlist, then download it if you want. That's for your own good. So questions also will be found in this playlist. Okay, I'll be just opening, I have there a lot. Thank you very much.